Greetings, this is Chemistry with Nav. In this video we're going to have a look at ionization energy, which is defined as the energy change when 1 mole of electrons is removed from 1 mole of gaseous atoms, forming gaseous 1+ ions. You need to learn these definitions because very often in exam questions you'll be asked to write equations that fit them. In this case I've shown in red a mole of sodium atoms, which are gaseous, turning into sodium 1+ ions, which are also gaseous, and an electron is lost. The typical sorts of questions that we get in exams are such as this. Describe and explain the trend in ionization energies going down group 1. So I want to show you a framework that makes life very simple to answer this and gets you the maximum number of marks really quickly and effectively. So start your answer. Set yourself up nice and easily. So going down group 1, colon. Now that everything that I answer I don't have to keep repeating myself. And the structure and framework that we use is this. We have N, we have S, we have R. And these are for nuclear charge, shielding and radius. So going down group 1, nuclear charge increases. Shielding also increases. And the radius also increases. Let's just look at those three things in a bit more detail. The nuclear charge does increase because as you're going down group 1 you have an increase in the number of protons. But this is outweighed by the radius increase. Because as you move things much further apart, the distance between them, the attraction, is going to fall off very quickly. The shielding will increase because there are now more shells between the outer electrons and the nucleus, and the radius increases because there are more electron shells. So essentially what we're saying is that the outer electrons are becoming more distant from the nucleus, and therefore the attraction is less. So this is the next part, is attraction. And the attraction between the nucleus and the outer electrons is reduced. So we have NSR and attraction, and now we need to actually answer the question. Thus the first ionization energy decreases. And that falls in line with, quick common sense check, falls in line with what we expect of group 1. They are becoming more reactive as you go down the group, which means that it must require less energy to remove that outer electron. So there we are. The other type of a question that you get on ionization energy is this. Describe and explain the trend in ionization energies going across period 2. So we're going to do the same thing. Going across period 2, and we're going to look at NSR again. The nuclear charge increases because as you go across any period you have an increase in the atomic number, so the increase in the number of protons. The shielding remains the same. And that is because you have the same number of inner shell electrons, full shells, inside the outer shell. The radius, well, as you go across, because you've got this increase in the nuclear charge, the radius is actually decreasing. So when it comes to thinking about the attraction, you have a smaller radius with an increasing nuclear charge, so the attraction must be increasing. Which means that overall the first ionization energy will increase. So keep your answers nice and simple for ionization energy questions. Set yourself up easily going across period 2, NSR, attraction, and then answer the question.